She's a good, loves her mom, loves Jesus in America. She's a good, is crazy about it, loves sports, and her boyfriend. It's alone. I'm a bad boy. Don't you miss her? I'm a bad boy. Breaking her off.
Oh, I'm free! Free falling! Alright, I'm an awful singer, you guys already know that. So, free fall, what the heck are we talking about? Well, we just got done talking about acceleration. So now we are talking about in 11.4, we're talking about free fall. And anytime you drop an object on Earth, what happens? Right? It falls. Why? Well, it falls because of gravity. So, it falls because of gravity. So free fall applies to any object moving towards Earth due to gravity. This is acceleration. All right, so this is acceleration. So anytime we are talking about the Earth's acceleration, we're going to be talking about 9.8 meters per second squared. So just kind of think about that. We're going to be talking about 9.8 meters per second squared. So anytime you drop an object on Earth, it is falling towards Earth at an acceleration of 9.8 meters per second squared. So just think about that. Anytime something is free falling, its acceleration is always 9.8 meters per second squared. So what I want to do here is I want to look at another example, but I want to focus on free fall instead of something else. So let's say here's my word problem. All right. I'm standing on top of a building. Right. I'm standing on top of a building, a 4-story building, and I drop a penny. All right. How fast will that penny be going when it hits the ground? So I'm standing, all right, I drop a penny from rest. All right. How fast will that penny be going when it hits the ground? When it hits the ground, it'll be in the air for 3 seconds. So one more time. I'm on top of a 4-story building. I drop a penny. The penny takes 3 seconds before it hits the ground. How fast is the penny going when it hits the ground? So let's talk about what we have. We want to solve for its final velocity. Well, remember, acceleration is equal to change in v over change in t. Since we are dealing with any object that is dropped on Earth, our acceleration is 9.8 meters per second squared. Our initial velocity is what? 0. I'm dropping the penny from rest, so my initial velocity is 0 meters per second. We are trying to find the final velocity, and the time is it took 3 seconds for that penny to drop. So what I'm going to do is now we're going to plug everything in. Acceleration is 9.8. That's equal to change in v over t, which is 3. Now, if that circle helped you rearrange things in the last problem when we were talking about speed, here is the circle. Here's the circle for acceleration. Acceleration is equal to change in v over t. So what are we trying to solve for? We're trying to solve for change in v. We're going to cover that up. Change in v is equal to acceleration times time. So we're going to take acceleration times time, 9.8 times 3. And when we do that, we're going to figure out that our change in v is going to be 29.4. All right. Now, change in v is equal to VF minus VI. That's equal to 29.4. We know that our VI was 0. So what must VF be? VF has to be 29.4. What is our unit for speed or velocity? It's always meters per second. Now, if you have a question on how we did this problem, this is one of the more complex acceleration problems. So don't worry about it. We will have time to practice in class. The biggest thing and the biggest application, guys, is this. Anytime you have an object in free fall, or anytime you have an object and you are studying acceleration and you're dealing with planet Earth, the acceleration is always 9.8 meters per second squared. So anytime you're dealing with Earth, the acceleration is always 9.8. So this concludes section 11.4, and it concludes chapter 11.